Let's get started. So let's walk through some statistics. So we'll talk about a few little things here, going through the little syllabus they give me so we can talk walking through it. So the concept of a population and a sample, all right, and random sample and a discrete and continuous data. Now the thing I've seen them test here is discrete and continuous. So if they give you some data, they might ask us real quickly, is that discrete or is that continuous? What is the difference between discrete and continuous?
Stop at some point, one go forever.
One could go forever. It's got multiple different things that could go there. One of the biggest things is there's gaps in the data. If there's gaps in the data, that's discrete. All right. If there's no gaps in the data, like it's continuous, like you said, all right, then that is continuous. All right. Reliability of data sources and bias in sampling. I haven't really seen a whole lot there. That's kind of some things that we have more that some of us include in our IA. Interpretation of outliers. I'm going to do one of those with you here in a little bit. You've got to understand that an outlier is, there's a formula for it, and they don't give you that formula. It's 1.5 times the IQR. So I'm going to address one of those here in a minute. But 1.5 times the IQR helps me to do that. Sampling techniques and their effectiveness. Random sample. There was about 4 different ones we talked about. Truthfully, I haven't seen them ask that before. Whether it's a systematic sample or a quotient sample or a convenience sample. That's some of the things that we did early on when we were talking about that. All right. Presentation of data, discrete and continuous. Frequency distribution tables. So you might be asked to fill in a table or fill in parts of a table. You might be asked to interpret or draw a histogram. All right. What's the difference between a histogram and a bar chart? One touches and one doesn't. Bar chart has gaps because it's discrete. Histogram is continuous and it's touching. You need to be able to find cumulative frequency graphs, median, quartiles, percentiles, range, and interquartile range, along with mean, median, and mode. So they could ask several different things there we talked. Got to understand a box and whiskers plot, how maybe to draw it or how to discuss it. Where's the median there? Where's the quartiles? We're going to go through all this. I'm just kind of walking through some of these things with you right now. Measures the central tendencies. So we got to do mean, median, and mode by hand and in the calculator. Don't get confused by that. If you say it correctly, it helps a little bit. That's not model. That's modal. All right. So the modal class is the mode because it's a group. All right. Measures of dispersion. We're talking about the range. We're talking about standard deviation. We're talking about variance. And there's some of those things we're going to be doing in the calculator strictly. We did standard deviation. I showed you how to figure that by hand because that's how far away from the mean I am. But that calculation is pretty intense calculation. That's normally a calculator problem. All right. Effects of constant changes on original data. All right. 10 years from now, when you come back for your 10-year, actually it'll be 11 years for most of you guys because you'll graduate next year. But 11 years from now, you'll come back for your 10-year reunion or something like that. And so, will the mean of your ages be the same?
Mm-hmm. Yeah.
Will the mean will not be the same. They'll be what? 11 years more, right? However, whoever's oldest in the class or whatever. But the standard deviation of your ages will be all the same. The spread, all right? Somebody will always be 5 days older than the other, and so forth. Okay? And so you got to be able to adjust, be able to change that as we're going. And then the quartiles of discrete data, being able to use technology to find that. We're going to talk about correlation coefficient later. I don't have any problems in there on that, but I do have a question from like last year or whatever that we need to discuss. I'll get to that. And then one other thing real quick here, just some probability, likely probability. We have the outcome that's likely to happen. It's our sample space. It's our universal event. All right, and so we're looking for a certain event A over however many different things there are. We have complementary events, so probability that A happens, the probability that A does not happen. all right, not A. So I gotta recognize that. Expected number of occurrences. What's my expected value? A lot of times that gets communicated as mean, all right? I'm gonna skip that for right now. The other thing I wanna look at right now is this. We need to be able to group things in probability distributions. We need to be able to make probability distribution tables, all right? Find the expected mean for that distribution and to look at applications. What is a probability distribution table? In this one, these are my outcomes. The outcomes would be I could get a 1, 2, 3, 4, 5. Maybe it's a spinner, and I could get a 1, 2, 3, 4, 5. Then I'm gonna list the probabilities for each of those things. Sometimes we get probabilities that are written like this in the form of an equation. So how do I get the probability? I plug the x in, so 1 would go in there and I'd find that value. I plug the 2 in and I'd find that value. I plug the 3 in and I'd find that value, and I could get the probabilities that way. Now, another question they like to ask is if I have a fair game, then the expected value should be 0. It shouldn't be biased one way or another. Whether I lose money or gain money or whatever the case may be. Okay? All right, so let's go to our packet. The first thing that I want to address, and we'll look at the formula sheet a little bit as we're going as well, but I want you to go all the way in the back of the packet. So if you were to take and you were to put the staple in the bottom right-hand corner, flip the packet over, and we have this problem right here. Okay? It's on the left-hand side. I think there's a probability tree next to it, but we'll get to that in a minute. All right? But we have this. This is a calculator problem, correct? But before we get there, there's a few things that we can do by hand. So let's talk about it by hand, and then we'll go verify our answer in the calculator. All right? Can't really do the standard deviation by hand. I can, but that would take a lot of work. All right? I'm not going to do that. All right? But could I write the median score? Could I find the median score by hand? Mm-hmm. How do we normally do median? It's the middle number, that's correct, and we normally write them all out, correct? And we cross off from left to right, or cross one off to the left, one off on the right, and keep going until I get to the middle, okay? Now, I don't know that I want to write all these out, because how many ones would I have to write? 3, and I'd have to write 5 2s, and this would be a lot of numbers that I'd have to write out. Right? So instead of writing it out, here's what I could do. I would cross off the 3 right there, and I would cross off 3 there, which would leave 5 of those left. That makes sense? Mm-hmm. Crossing 3 and 3. We cross off those 5 and those 5. And the crazy thing here is I would cross off these 10 and those 10, so my middle number is actually in the middle between 4 and 5, which would be 4.5. It'd be 4.5. So our middle number here is 4.5. Now, the interquartile range. If I'm finding the interquartile range, if I'm doing a box and whiskers plot, the interquartile range is from the left-hand edge to the right-hand edge. How wide is that box? That's your IQR. Okay. Well, I can find my IQR, I can find that from my picture here as well, because if I'm looking for Q1 or I'm looking for Q3, then that's the median of the median. So we just found the median, it's right there. So we would go find the middle number over here. All right? So if I were to go find my middle number there, my middle number, if I did the same thing, I could cross off 3, cross off 3, cross off 3, cross off 3, and then those 2. So my middle number left over would be a 3 there. So 3 would be that left edge. That's Q1. See what I did there? I found the median, and then I found the median of the median, which is a quartile. Right? On this other side, it's a little bit easier because I would cross off 8 here and 8 there, and I'd still have 2 left over for the 5, so that would be 5. Now, I put those first. I didn't put the 4.5 in there. The 4.5 is the line that's in the middle of the box. But in this case, would that line be just square in the middle? It would be skewed a little bit, right? Because it's 4.5, the median's 4.5, so that would be closer to 5. So I wouldn't be right in the middle, I would be more like this. That's where I would put the 4.5. The value that goes here would be 1, because that's the lowest number. The value that goes here would be 6. So I helped you to construct a box and whiskers from that, okay? Now I didn't need to do all that. I did some of that just to kind of review. Could I find my interquartile range? What is my interquartile range? It is the difference between 5 and 3, which would be 2. All right? If it's asking about the total range would be the distance from the whisker to the whisker, which would be 5. Okay? Now, when I'm looking at this, how much information is in that box right there? In this box and whiskers, how much information is in that box? 1/4 of the data, 25%. Okay? So 25% of the data lands in that one, 25% of the data lands there, 25% of the data is on that whisker, 25% of the data is shown there. Okay? Now, I mentioned this a while ago, and I'm going to talk about it right now. If it asks for an outlier, all right, is 1 an outlier? If 4.5 is the middle number, is 1 an outlier? Are these 3 ones, are they outliers? The way that we would do that is we would do 1.5, that's the equation, 1.5 times the IQR. Our IQR we found was 2. So 1.5 times 2 would be 3. Okay? Now what do we do with that 3? We measure from the edge of the box out. So we measure from there to there. We go -3. We go from here to here, and we go +3. And that is my allowable distance. Okay? So if I did 3 minus 3, I would be at 0. So anything lower than 0 would be an outlier. Okay? I would take 5 plus 3 and I would get 8. So anything bigger than 8 would be an outlier. In this case, none of these are outliers. Everybody okay with that? Now, I would start this. I would make sure I knew this. It's not on my FOMA sheet, but I have seen them ask that question a lot. And it's not a difficult question, but if I forget the 1.5, then I'm kind of losing points there. All right, so I got to remember that little formula. Okay? Now, let's go do this in the calculator. If I were to do this in the calculator, how do I enter something like this in the calculator? Where do I go? Say again? Where do I go? List and spreadsheets. All right? The list and spreadsheets. So I'm going to walk you through, again, some calculator work. And so I'm going to say this is X and this is Y. And this is 1, 2, 3, 4, 5, 6. And I believe this is 3, 5, 4, 6, 10, 8. Is that right? So I've got that in. Again, make sure that you label it. If you don't label it X and Y, then it won't do the next step. All right? So I'm going to go Control Doc. I'm going to go to my calculator page. I'm going to go to Menu. What is it that I'm going to ask it to do? It's going to be Statistics, yes. Statistics, Stat Calculations, and this is one variable Statistics. Now you're going, well, no, there was 2 columns. There's an X and a Y. But what did the Y column stand for? Frequencies, how many times that occurred. So it's not actually a variable, all right? If I was comparing shoe size versus height, then that would be 2 variables, all right? But I've got, what was it, a score, all right? Or how many times, and then how many times did that happen? That's frequency. So I actually only have one number list. My number list is X. My frequency list is Y, okay? If you leave that frequency list as a 1, then what it's saying is it's gonna take each of the x's that you put and it's only gonna count them more than once. Alright, but I don't want that to happen, I want them to count it, and I already have there, it's gonna count it y. If I do that, I hit OK, it gives me a lot of data. We notice that the median is 4.5, that's what we got by hand. We notice that Q1 was 3, Q3 was 5, we got those by hand as well, alright? But the other thing that you need is you need this little circle, this little O with a hat on it, with the cap on it. That is your standard deviation. So the thing that we skipped a while ago was standard deviation. Your standard deviation is 1.61. So on that information, that's where we would, now, you see why it's a write down problem? They're saying use the calculator, go find it. That's why it's a write down. So that's what we have there. Okay? Everybody all right with that one? All right. Next. What I'd like to do is I'd like to jump to, when we think probability and statistics, we look at this. All right, so I want you to find this one in there. It's got a bunch of dots on it. So question number 8. So what do you notice about what they gave me here? They gave me dots instead of what? The actual numbers, right? They kind of set it up for me, but then they're like, I'm not going to give you all the answer. I'm going to give you a little hint, but I'm not going to give you the whole thing. This is a sample space diagram. You could build with this if you like on your own. Sometimes they'll provide it for me. I have that. So let's do this. This is simple probability. Let X be the sum of the dice, scores on the dice. What is the probability that X equals 6? Anybody get that? When does my sum equal to 6? 3, 4, 2, 5, 1. It's that diagonal right there. Which is how many? 5. Out of? 36. Okay, so 5 out of 36 is that one. Okay? How about the next one? Probability that X is greater than 6. Where is it talking about now?
Less than 6.
All these dots down here. Right? So I'm going to count those dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 19, 20, 21. 21 out of 36. Okay? Next part it says, what's the probability X is equal to 7? What's that vertical line mean? Not or in that case. Say again? Not and. It's a conditional. It's given. What's the probability X is 7 given that X is greater than 5? Do I have to start over with this problem?
No.
What numbers are greater than 5?
6.
6 or greater than 6. So how many? 26. Right? I don't have to start back over. So if I'm reading carefully. So there's 26 numbers out of 36, and how many of those are 7? 6 out of 36 or 7. Well, do I really need the 36s? They should cancel. Alright? So I'm left with 6 over 26. Some of you that bothers that it's written like that because you would rather write it as 3 over 13, right? But I can leave it like that, that's fine. So what did I use? I used my formula sheet. When I use a given, anytime I'm using a given is reduces the sample space. It is this formula right here. The probability of A given B, the way that I do that is the probability of A and B go on top, and the probability of B goes on bottom. So the probability that I was bigger than 5 was 26 out of 36. That's what went on bottom. The probability that I'm 7 and bigger than 5. Well, can I be bigger than 5 and not be a 7? Yeah, all right. But can I be a 7 and not be bigger than 5? No, so all my 7s are going to work, correct? So 6 out of 26. So I use that formula there to set that up. Everybody okay with that? All right. Then it goes a little bit farther. All right. If you haven't done this, read part B real quick. So we had some kind of basic probability at the top. Now we're using a probability distribution table here at the bottom. So I'm going to help you set that probability distribution table up at the bottom. So X and probability of X. All right. What are the outcomes when I play this little game? I can do what? I can win 3 points. I can win 1 point, or I can lose K points. All right, so that's the 3 things that can happen. What's the probability that I win 3 points? Say again? All right, got to have a sum of 6. What's that probability? Do I have to start over? No. Nope, I answered that question already. There it is. 5 out of 36. So 5 out of 36 chance that I get that. Greater than 6, she wins a point, which is what? 21 out of 36, thank you. And then what's the probability that she loses? Well, I could go back to the top and do it. I could do this from right here, though, without having to go back and count it. Because if this is everything that happens, what does my probability have to do? Add up to 1 whole, all right? So if these are the 3 things that can happen, all these have to add up to 1 whole. Well, if I have 26 out of 36 right now, then I have 10 out of 36 left over, okay? You could go back up at the top and count it if you like, but it should be 10. Everybody okay with that? So I've got that there. Now, it says find the value for K, which Elena's expected number of points is 0. This is a fair game. So if I were to do expected value, I would get expected value to equal to 0. So how do I find expected value? I multiply. I multiply the result times its probability. I multiply the result times its probability, result times probability, and that should equal the expected value. So 3 times 5 over 36 is 15 over 36. I like multiplying by 1, that's easy. 21 over 36 plus negative 10K over 36. And that should equal my expected value, which is 0 in this case. all right where these numbers came from, what I did there. Now, I'm gonna multiply by 36 because they're all 36. So if I multiply by 36, then that gives me 15 plus 21. I'm gonna move the 10K to the other side, so it's gonna be positive. So I have 36 equals 10K divided by 10, and K would equal to 3.6. So I'm gonna lose 3.6 points if I roll there. That way this game is fair. Every party has an equal chance of winning or losing. Okay? Everybody good there? All right. So what I want to do is I want to go back towards the end of the packet again. Sorry, these are kind of mixed and stuff as we're going. And I want to look at this problem right here. All right, we have a test. The test has 5 questions on it. You gotta get at least 3 of them right to be able to answer correct or to pass it. So you gotta make a 60% to pass it. The probability that he guesses correctly is 1/5. What is the expected value? So how many will we expect Mark to get correct? Well, if you look at your formula sheet, there is a formula in the formula sheet that addresses expected value as well. All right, expected value is equal to n times p. Expected value is equal to n times p. What is n? N is the number of trials. There's 5 questions, 5 trials. P is the probability of success, which would be 1/5. So 5 trials times 1/5, I would expect to get 1 answer correct. What should happen? Okay. Probably not a very good chance he's going to pass this test. Find the probability that Mark passes this test. Now, this is where I need my calculator to assist me. This is a calculator problem, correct?
Yes.
Okay. And so this distribution that we're talking about here, it is a binomial distribution. All right? Because what could happen? I get the answer correct, or I get the answer wrong. All right? And so there's only 2 things that could happen. So it's a binomial distribution. So if you take your calculator and you were to go here, I'm going to go menu, and I'm going to go, I've got a choice here. I could go probability, and I have a menu of distributions, or I could go statistics, and I have a menu for distributions. Either way, I need to go to distributions. If I look towards the bottom of this menu here, I've got 2 options. I've got a binomial PDF and a binomial CDF. Okay? What is the difference between PDF and CDF? Yeah, that's why we're reviewing.
CDF is like a specific point or like 1 or something like that.
The other way.
Yeah. It is the other round. C stands for cumulative. So if I get multiple answers that I need, that's cumulative. The P stands for precise, and that means exactly 1 answer. All right? So in this case, if I'm going to pass, how many different ways could I pass? I could get 3 questions right, and get 4 questions right, I could get 5 questions right. So that would be a cumulative deal. All right? So I'm going to pick binomial CDF. It's going to ask me a couple questions. How many trials? Well, 5 questions, so 5 trials. Probability of success would be 1/5. And what I want is I want to get 3 right is my lower bound, and I want to go to 5 is my upper bound. Okay? So if I do that, then the probability that, is this marked? Right, I think it's marked. Probability that Mark has, passes the test is 0.0579. Mark doesn't have a very good chance of passing that test.
That's so.
Alright, 6% chances of passing the test. That's not very good. Okay? So basically what I did is this. I didn't write this whole out like we did just a second ago, but his probability distribution table would have looked like this. And we could go get the probabilities for all those, but we really only want those probabilities here because that's when he passes. Okay? But I let the calculator do that for me. All right. Now, let's take a look at Bill. On Bill, they give me his probability distribution table. That was nice of them. Except what did they do? They've got some letters in there. They've got some variables. Okay? First thing it asks me to do is show that this equation is true. Anybody got a thought on how we could get that equation right there?
For A and B.
We are going to solve for A and B. But what do we know true about this probability distribution table that it all adds up to 1? That's correct. So if I were to take all these right here and I were to add them all together, then that should equal to 1. That's the thing that we do know. If I start looking through there, A plus 2A is 4A. I think I'm on the right track. All right? And so 2B, and then that B and that B cancel, so 2B. And then 67 plus 5 is 72. Plus 4 is 76. So when I add all that up, I would get this, and then my final move would be to do what? Subtract this. So subtract the 76. Sorry, looked at it incorrectly. So I have that, and so now it looks just like that. Okay? Everybody all right with that? That is a big thing that they're going to ask. At some point in time, you're going to have to add all those values up, and you got to know that they equal to 1. Okay? Could I solve this equation right now? Not really. Why not? 2 variables, only 1 equation, right? So I need 2 equations to solve 2 variables. So that's where we're going with the second part. It says, given that the expected value is 1, find A and B. So how do I find the expected value in this situation? Multiply, and multiply, and multiply, and multiply. Multiply all these, and then we're going to add them all up. And it's going to equal to 1, because that's what it said. All right? So if I were to do that, I like the first one. That's easy. So I have 0 plus 0.05 plus 2 times A and 2 times 2B, 3 times A and 3 times negative B, 4 times 2A, 4 times B, and then that would give me 0.2 when I multiply those together. Everybody okay with what I did there?
Yeah.
I multiplied. I had to do a little bit of distributing. Okay? I'll put my A's together. So I have 10 and 3, so I got 13A. I've got 4B, 4B, and negative 3B, so I have 5B. Plus 0.05 and 0.2, so 0.25, and that equals to 1. You want to move that 0.25 over? I would. So that it looks like this, and that looks really similar to that right there. All right? So I got 2 equations. Now I can solve. Calculator or non-calculator? This calculator, right? What's the easiest way to solve that one? The calculator? Yep, that's where I'd go. I'd go menu, and I'd go algebra, and I'd go solve system of linear equations. Boom. two equations. And I have 4x plus 2y equals 0.24. And I have 13x plus 5y equals 0.75.
It's not letting me go there.
Huh?
It's not letting me go there.
It won't let you go there?
It's probably locked.
It's locked. I'll fix it.
Okay.
You will have that for the test.
Okay.
There is no lockdown on the deals. They will be completely. You have access to all of them. All right. So you'll have access to that. Now, if it was locked, where else could I go? What else could I do with this? Could we go graph it? You could go graph it. You could use elimination and substitution, which that's not too bad. So if I did that, I would probably have multiplied this one by 5 and this one by -2, because that would give me 20a plus 10b equals 1.2. Multiply by 2 there, get -26a, -10b equals -1.5. The b's cancel. I get -6a equals -0.3. Divide by -6. So a equals 0.05 there. Only bad thing about that is now I gotta go plug it back in to go get the answer. So that was, if they ask you to do that by hand, it'd probably be a little bit easier numbers. All right. So we got 0.05 and we got 0.02. So we found A and B. Now, it goes one step further. It says, okay, so who's more likely to pass the test? Well, we know Mark had a probability of like 6%. What does Bill's probability? I want these three probabilities right there, because that's passing. 3, 4, 5 questions right. So I'm going to go A minus B, so 0.05 minus 0.02, so that'd be 0.03. Multiply there, so that would be 0.1 and 0.02. So that would be 0.12, and then 0.04. So if I put all that together there, 15.19. Did I do that correctly?
Yeah.
Because you got a different answer yesterday, but I think I did it right today. I must have had Monday math yesterday. All right. So I had that. So he's got a 19% chance of passing. Still not great, but better than the other. So Bill's probably got a better chance of passing. Good. Everybody good there? All right. We're not going to go too far. Let's just flip the packet over and let's go look at this question right here. I think you just can flip it over.
Okay. Yeah.
This is a cumulative frequency diagram. I like these questions. I wish they would ask more of these. I think they're pretty easy. All right. How do I find the median for this? Huh? You go to 40. You go halfway. The median's halfway. It's the middle number, so I would take 40. I'd run it across, and I'd run it down. I got to check my scale to make sure I understand what the scale is. Those are counting by 2, so that'd be 32 would be my median. Okay. Find the IQR. How do I find the IQR? Got to go 25 and 75%. I got to go the middle of the middle. So that's the middle. Q1 would be here at 20. So I would take 20, run it across, and that would give me 22. 60 would be halfway there. I would take it, run it across, and run it down. And that would be 40. And so that would give me 18 would be my IQR. Alright, now, let me talk about a little bit something else here where they might ask another question here. They might ask, what is the 90th percentile? Okay? If they ask for 90th percentile, okay? What is the 90th percentile here? I would take the 80 that I have, that's the total, and I'd multiply it by 90%. So that would be 72. I'd take 72 now and run it across, and I'd run it down, all right? And so 48 would be my 90th percentile, okay? You actually do percentiles, or we did percentiles a while ago, because what was Q1? Q1 is the 25th percentile. The median is the 50th percentile. Q3 is the 75th percentile, okay? Now, this has another little part to it. If you flip the packet back over, you have this table right here. And it asked me to complete this table here. How is this table different than what that graph is giving me?
It's like a histogram, ranges.
It's more like a histogram. It's giving me ranges. Are these adding up as I'm going along? It's not cumulative, is it? All right? And so to get the graph that we just have, what we would have done is we would have taken that and got that first one, then we would have done this one and added those two together to get that second one. So on the graph is going to tell me 0 to 20 is what the graph is going to tell me. All right? So if I were to go look at the graph and I were to look at 20, which is almost right here where the red is. I'm going to delete that real quick. If I were to do 20 students right there, or 20 time is my time, run that across, then that is 16 students. 16 students take this test or whatever this is in 20 minutes or less. So what would go here? 11. Because those two things added together have to give me the 16. So altogether, from 0 to 20 is 16 students. We know that 0 to 10 is 5 of them, so 10 to 20 must be 11 of them because they have to add together to give me that. Okay? Now, how could I go about finding this missing one here?
74. Just add them all up and subtract it from 80.
That's probably what I would do. All these have to add up to be 80 because we tallied 80 students, correct? So if I did that, I could say 24 and 6 is 30, 50, 66. So there's a difference of 14. So I can do it that way. Absolutely. Or if you would like, you could do it this way. What I would do on my graph is I would say, okay, at 40, which we know 40 is 60 students. 60 students spent less than 40 minutes or less. If I go to 50, run 50 across, 50 is this one right there, run it across, and that is 74. So 60 was that one, that's 74. Find that difference right there, that's that same 14. Okay? I like it when I just have one missing. That makes it pretty easy. Because I think the lower end of these are a lot easier to find than the upper end. Okay? So that's cumulative frequency diagram. I'm not going to spend a lot of time there, but it got you one there. Okay? All right. Let's do this. I want to go to this one right here. Go back a little bit. There's one that's a question number 5. It's not really big. It says the probability of obtaining heads on a biased coin is that the coin is tossed 7 times. We're going to discuss this one, then I'm going to give you one to do by yourself, and then we'll take a little break. All right. By the way, is this normal right here for a coin?
No.
No, it's normally 50-50, right? So this one's biased or whatever, so it looks like that, so pay attention there. Find the probability of obtaining exactly 2 heads. How many times did I flip the coin? 7 times. 2 heads. Now here's the thing, this is where it gets a little bit complicated here. I could have flipped the heads the first 2 flips and then tails the rest of the way, or tails and then 2 heads at the end, or maybe 1 head at the end and 1 head at the end, beginning and end. There's a lot of different combinations. Well, I don't have to know all this. This is a calculator one. It's going to do this for me. Because of the word exactly, what am I going to use? PDF, that's correct. This is binomial, heads or tails. That's what I got. 2 things. It's binomial PDF. So I'm going to go to my calculator. I'm going to go menu. I'm going to go statistics or probability, either one. Distributions, binomial PDF. There are 7 trials. The probability of success is 0.18. And I'm looking for exactly 2 of those. If you didn't put the 2 in there, it's going to give you the probability distribution table. It's going to list all of them, all right, for you, which you may want, or in this case, you don't really want to. So the probability that that's correct is 0.252. Find the probability of obtaining at least 2 heads. How's this one different? At least. So now there's a lot of different answers, right? So I want to go from 2 all the way to 7. So now which one am I going to use? CDF. By the way, could you use PDF and do every single individual one and then add it all together? Mm-hmm. Yes, but I wouldn't. Okay? So statistics and distributions, and it is B, or binomial CDF. 7 is my number of trials, 0.18, and my low number is 7. My low number is 2. My upper number is 7. So on that one, 0.638. Okay. So 0.6368. All right. Here's what I'd like for you to do. We have another problem just like this, or very similar to this. I think you have to turn the page, maybe flip the packet over. Yeah, all you gotta do is flip the packet over. All right? I want you to try that one by yourself. here we go. Find the expected number of questions that Jose answers correctly. How many answer correctly? What would be the expected value? 2. This is that n times p problem. N is 10 questions, p is 1/5. If I multiply that together, I get 2. All right. What am I going to use for part B? PDF, because it's what? Exactly. All right. And so my number of trials is 10. My probability of success is that. The X value that I want is 3. And when you did that, you got 201. I think that was 0.201. I believe that was the thing that we got yesterday when we were done. Okay. Now, this one's tricky. This one's what? PDF or CDF? This is CDF. All right. All right. CDF. All right. But what is my range on that one? 4 to 10. It says more than, so be careful. All right. So 10 is the number of trials. 1/5 is probability of success. My low range is 4. My upper range is 10. So what I would do there, they kind of slipped that in on me, so I got to be careful. All right. And what did you come up with on that one? Probably that's what I got. Yeah. Good. Everybody good there? All right. So I'm going to pause there for a moment and pause the video and things like that. If you need to use the restroom or something like that, that'd be fine. Okay. And then we'll continue about 10 minutes.